Okay, if you watched the last video, that was properties of exponential functions part 1, we went over different properties where our a value or our base was greater than 1. So if our a was greater than 1, and I said that would be things like 2 to the x or 3 to the x or something like that. If you'll remember from looking at that one, our graph did something like this. We had all those properties we talked about, and this it was a monotonic function increasing over its entire domain. Now we're going to be looking at an exponential function, but where our a value or our base is between 0 and 1. So for this case, we're looking at things like 1/2 to the x or 1/3 to the x. That's what this picture is going to mimic. So let's look at our properties and see if anything really is different. This one says the domain is the set of all real numbers. Well, wasn't that true for our other exponential property that we looked at earlier? Absolutely. The domain of the exponential is all real numbers. The range is the set of positive real numbers. It doesn't matter what the base is. Those are both true always. So we don't have to separate them. We can just say, period. The domain is all real numbers. The range is positive real numbers for all exponentials. There are no x-intercepts, and the y-intercept is 1. Well, we saw that same thing a while ago. We had the x-axis acted as a horizontal asymptote, so there are no x-intercepts, and the y-intercept was at the point 0, 1. Same exact thing here. So again, it doesn't matter what the base is. That is just a property of exponentials, no matter what. Number 3 says the x-axis is a horizontal asymptote as x approaches infinity. Well, in the last set, it was as x approaches negative infinity. As we got closer in the negative region, the graph went more towards the x-axis. In this case, it's as we go to the positive side that the graph gets closer and closer to the x-axis. But even at that, it's a minor difference. We can say in general terms that the x-axis is always a horizontal asymptote of the exponential function. So far, the first 3 were the exact same no matter what base we were talking about. Here on number 4, it says if your base is between 0 and 1, we have a decreasing function and it is 1 to 1. So this is the only real difference between the two functions. If our base is larger than 1, we have an increasing function. If our base is between 0 and 1, we have a decreasing function. And again, it's monotonic. That means that it's happening, it's doing one thing over its entire domain, mono meaning one. Okay, number 5 says the graph of f contains the points 0, 1, 1a, and -1, 1 over a. This is exactly the same as it was for our bases bigger than 1 also. So far, 1, 2, 3, and 5 are the exact same no matter what your base is, the same properties. And number 6 is also the same. The graph is smooth and continuous with no corners or gaps. So these properties, we really could learn one set of properties, and it works for no matter what the base is. The only difference is if our a value is bigger than 1, the graph is increasing. If the a value is between 0 and 1, it is a decreasing function.